Hello. So we're now on false position method. So which is another method under the bracketing method. So which is used in finding a root of a given equation. So through bracketing approach. So that means so we have two initial values. So in finding the roots of a given function. Comparing the false position method to bracketing method. So false position method uses the principle of slopes. And from here, so using the two similar triangles and equating the two, so that will yield to a an xr value, so which is equal to x sub u. Okay, so minus f of x sub u times x sub l minus x sub u over f of x sub l minus f of x sub u. So the method in finding the roots of a function is the same as the bisection method. So the only difference is the formula in finding the value for x sub r. So by the way, false position method uh, has other terms. Okay, so particularly, so regular falsi is the most common one. So regular falsi or false position method is the same approach or the same method. False position method is a bit faster, okay, so as compared to the bracketing method or to the bisection method. So as you can see here, so the steps for false position calculation is exactly the same as that of the bisection method. So the only difference is our calculation for the x sub I. So we will be answering the same problem, but we're just going to be or we're going to use, okay, so regular falsi or the false position method. So since we already solved this to one, so I'm going to skip the step number one because we are already sure that our root, okay, so one of the root is in between 0 and 1. So we'll proceed right away. So in estimating for the value of the x sub r. So that is, so we can do our first iteration. So the formula that we will be using is that, so x sub r is equals to x sub u. So minus the f of x sub u multiply it with x sub l minus x sub u all over f of x sub l minus f of x sub u. Okay? So that is how we find our x sub r. So in this case, it would appear that our x sub r is equal to 0, and then our x sub l is 0, and then x sub u is 1. Okay, and we find, okay, so for the value of f of x sub l, so which is the f of x sub or f of 0, so where f of 0 is negative 2.3, so negative 2.3, and our f of x sub u or f of 1, so just to recall, okay, so we have 4 alpha x raised to 3, then we minus 6 x squared plus 7x, then minus 2.3. So that would be 0 or 0, then we have 1. The step size is 1 as well. So giving us to have a 2.7. So now that we have this, so we can compute for our x sub r. So using our formula, our x sub u is 1. Then we subtract f of x sub u, so which is 2.7. Multiply it with x sub l, which is 0 minus 1. Divide it with f of x sub l, so which is negative 2.3 minus f of x sub u, so which is 2.7. So our x sub r then will be 1 minus 2.7, so times 0 minus 1, then divide it with negative 2.3 minus 2.7. And based on our answer, so x sub r is approximately equal to 0.46. 0.4600. Okay, so that's the value for x sub r. And then we follow the same process. So that is, we need to find out, okay, so whether our roots, okay, so lie at the lower interval or at the upper interval. Okay, so we already have our f of x sub L, so which is our f of 0, and that is negative 2.3. So what we don't have is the f of x sub r, so which is the f of 0.46. Okay, so I'm going to write again. So f, so raised to 3, and then minus 6x squared, and then plus 7x minus 2.3. 467, 2.3. So 0. So I'll start with 0. I'll end with 0.46. 0.46. And I'll end with 0.46 as well. So 0.46 is approximately equal to positive 0.397 or 0.397. 0.0397. Okay, so as we can see here, so we check the same thing. So the lower interval, so f of x sub L, so multiplied by f of x sub r should be less than 0. So it would appear that this is negative, f of x sub r is positive. So therefore, the answer would be negative. Negative is less than 0. So therefore, the root lies, okay, at the lower portion, okay, or the lower interval. So it is under 0.4600. Okay, so that is for the first iteration. Okay. So next, let's proceed with the second iteration. So for the second iteration, so since we are accepting the lower portion, so therefore our x sub L is 0, and then our upper value for x, so would be 0.46. So we now compute for the new value of x sub r. So for the second iteration, our x sub L is 0, then our x sub u is 0.46. So we identify what is f of x sub L, or f of 0, so which is negative 2.3, and then our f of x sub u, so which is f of 0.46, so which we already solved. Okay, so that is negative 0.3, negative 0.0397. Or sorry, it should be positive. Okay. So it's positive 0.0397. So now, so we compute for the new x sub r, so that is x sub u, so which is 0.46, then minus, that is f of x sub u, that is 0.0397, then x sub l, 0, minus x sub u, 0.46. Then we divide it with f of x sub l, so which is negative 2.3, then minus, so 0.0397. So f of x sub l, so minus f of x sub u. So we can now have our new value for x sub r, and that is 0.46, so minus 0.0397, so multiplied it with 0 minus 0.46, then divide it with negative 2.3, so minus 0.0397. So our answer will be 0.4522. 0.4522. So now we can compute for the approximate error. So the approximate error is the same as the present, okay, so which is 0.4522, and the previous is 0.46. So divide it with present, so which is 0.4522. So the approximate error will be 0.4522. Sorry. 4522, so minus 0.46, so divided with 0.4522, so times 100. So 0.4522, so multiply or minus, okay, so 0.46, then divide it with the present, so which is 0.4522, so times 100%, so the error is approximately 1.72%. So it's already below the accepted value of 10%. So look at this. So this one is faster, okay? So as compared to that of the bisection method, okay? So it's because of the principle of the slope here. And that will be also for the Regula Falsi method. Good day.